What other kinds of conversions can we do? We convert fractions to decimals and decimals to fractions. I want something else, Mr. Starling. What else is there? I've got just the thing for you. Percent. It's got nothing to do with smell. It's got nothing to do with money. Okay, well, sometimes it has something to do with money. But percent, P-E-R-C-E-N-T. Boom. Whoa, percent. Now, cent. How many cents are in a dollar? How many cents are in a dollar? Well, 50 cent is like Curtis Jackson and half of a dollar. So a dollar must be 100 cents. Cent. How many years are in a century? Well, a century, C-E-N-T-U-A-R-Y, something like that. Century has the word cent in it as well. And how many years are in a century? 100. So what do you think cent means? It means 100. What about the per? P-E-R. What's that all about? Well, percent. If it's percent, it is for each 100. So the per means for each. For each 100. So if I have something that's 72%, that means out of 100 things, 72 of them are that. Let's say you've got a percentage of cars on the road are 4 doors. Let's say you say 64% of the cars on the road are 4 doors. That means if you sit and count cars, every time you count 100 cars, you should come out with about 64 4-door cars. Percent for every 100. Now, here's the cool thing. What do you know? We've got some percents now. Let's convert our percents to fractions. Everybody likes fractions, because what are fractions? They're just division. Nothing special about it. A fraction is division. So, what about this stuff? Let's convert it to a fraction. We said percent means for each 100. So this is 50 out of 100. Let's write that down. Let's write down the next one too. 36 out of 100. Okay, so that's written down. What can we do with that? Both of those are reducible fractions. We can use our factoring to make those smaller numbers. How many 50s go into 100? 2. So let's make it 1/2. How many 36s go into 100? That's kind of an odd number. Don't put 36 divided by 100 into your calculator and expect something other than 0.36, because it doesn't do this evenly. 36 over 100. Let's see what factors we have in common. Factors of 36 are 2 and 18. So we'd take out 3 out of 18, that's 3 and 6. So 2, 3, 6. And 6 is 2 and 3, so that's 2 2s and 2 3s. Poof. So we've got our 36 factored. 2 2s, 2 3s, not the ballerina kind, 2 number 2s. How does this work with 100? Well, let's think this through. 2 2s. 2 times 2 is 4. And how many quarters are in a dollar? 4. Mr. Starling, you didn't do that all the way down to prime factorization. No, I didn't, because I knew that this has 2 2s. 2 2s are 4, so that means 4 and 4 will cancel. I'm left with 25 from the 100, and I'm left with 2 3s from the 36. 3 times 3, let's make it back into 9. 9 does not go into 25 at all. Certainly not evenly, at least. Pa-ching! 9 25ths. That is the reduced form of the fraction. It's an equivalent fraction. Equivalent fraction. We could go through and cross multiply. 9 times 100 is 900. 36 times 25. Believe it or not, It's 900. I'll give you a minute to do that on your calculator if you'll press pause, but I'm going to keep going. So I hope you pressed pause if you wanted to keep doing that. What about this other one? We've got 110%. Wait. 110%. That is 110 for every 100. That's more than what you have. How does that even work? It only works in one way, and that's when you're talking about percent change. If you're talking about percent of a thing, percent of a population, percent of a group of stuff, if you've got anything other than percent change, 110% does not work. So if the coach ever tells you to give 110%, don't argue with them. They're the coach. They'll make you run or do push-ups or something horrible like that. I don't even want to think about it. I don't work out at all. But don't argue with the coach. Just know inside that you can't give 110%. At least I hope you can't give 110%. I mean, if you give 100%, that's giving all of you. That's giving your all, and that's great because that means you're really committed. But that 10%, that extra 10% of a human, if you've got like extra legs, and arms, and stuff sitting around in a box at your house, the cops really want to talk to you. Like right now. 110%, only good for percent change. 110 over 100, 110 per. Now, cool thing is, we can factor that. 110 and 100. Watch me do this real fast. Boom! 110 factors into 10 times 11. 11 is prime, but 10 factors into 2 times 5. So, 110 is 11 times 2 times 5. 10 times 10, though, is 100. So, 100 factors into 2 times 5 times 5 times 2, because each 10 breaks into a 2 and a 5. What can we cancel out? Well, I'm glad you asked. Look at that. We can cancel out some 2s and some 5s. How many? 1 of each. 1 pair of each. Those 2s are gone. Those 5s are fired as well. What am I left with? 2 times 5 and an 11 up top. Let's go ahead and put that down as our answer. For my answer, I did not leave the 2 times the 5. We know 2 times 5 is 10. We shouldn't need our calculator for that. It's okay if you did, though. But here we are now. We've got 2 times 5, 10. That makes it a better answer because we are only showing one kind of math in our answer, division. Fractions are division. Fractions are division? What about 19? 19 is a percent. Percents are division too, because that's 19 per 100. 19 divided by 100. 19 is prime. We don't have to reduce that one at all. So here we are. We've got 19 over 100, nothing to reduce. We have 2 zeros, just like the percent sign. The percent sign over here on the percent side has the percent with 2 little zeros and a slash. Each zero reminds you it is 2 zeros in your 100 per 100. That's the idea behind percent. Poof.